Okay, today is October 7th, 2011. We're doing lesson 2.3. The first example is a farmer. He has a whole bunch of sheep, and he has 20 meters of fencing. Okay? He needs to maximize the area of a pound for all of his sheep. So, in other words, he needs to use this fencing to set up an area to put his sheep in. So, he has several different shapes. He wants to make it a four-sided shape. We're going to go through several of the options he could use. So, we're going to throw down a couple options here. Now, if he has 20 meters of fencing, what that means is the perimeter, or P, of all of these objects, or these shapes, is going to be 20 meters. So we need to set this up with our width and our length. And we need to set it up so all together, when we add all of the widths and lengths together, it's going to be 20 meters all the way around. So one of the options could be if our width was, let's say, 2 meters. That means our other width is 2 meters. Okay, so far we've used 4 meters of fencing from the perimeter. I have 16 meters left. I have to divide this 16 meters into 2 equal spots. So both of the other sides will be 8 meters long. That's one option we have for fencing. Another option we could use is if, let's say, the widths are 4 meters by 4 meters. In that case, we've used 8 of the meters of the 20 meters of fencing. Nope. Which gives us 12. I have to divide the 12 by 2. The other length will be 6 meters long. Another option could be if we have 5 and 5 for the widths. What will our lengths be then? 5 again. And let's say we go back to 4 and 4. What will our widths be in this case? Yeah, we've already figured that one out. So I could draw all of these options out and then calculate the area for each of these. But what I'm going to do is I'm going to make a chart to solve this. Okay? So I want you guys to copy down this chart. Okay, so I've set up the chart. L is for the length of a side, W is the width, P is our perimeter, and A is our area. We know our constriction is all of the perimeters are going to be 20 all the way down for all of our different shapes. This is a different option than drawing out every shape. As you guys notice above, we drew out a couple options. We're going to put it in chart form. So the smallest one, we're going to work with whole numbers. We assume the length will be 1 meter. Okay? So if the length is 1 meter, and there are 2 lengths, that means 2 of the meters will be used. That gives us 18 meters left to work with. So the other sides will be 9. 2.3. And, okay, so what we'd figured out before was all of our perimeters will be 20. And we have to create shapes. So in order to get perimeter, we have to add both lengths and both widths together. So if the lengths are both 1 each, and the widths are both 9 each, when we add all of these numbers together, 1 and 1 is 2, 2 plus 9 is 11, 11 plus 9 is 20. We end up with our 20 meter perimeter. Now what's important in this is we're looking for the area. So we're actually going to multiply just one of the lengths times one of the widths. So 9 times 1 gives us an area of 9, and everything's going to be in meters squared. But we're trying to maximize area. So we're going to try with a larger length. In this case, we're going to have 2 and 2, which makes 4. I subtract 4 from 20. I get 16 divided by 2 is 8. So when I add 2 plus 2, I get 4. 4 plus 8 is 12. And 12 plus 8 gives me my 20 meter perimeter. And again, we're going to multiply just one of the lengths and one of the widths. Already my area has jumped quite a bit. It's 16 meters squared. We're going to continue this pattern all the way down. 3 and 3. That's going to give me 6 minus 12. Give me 14 divided by 2 is 7. So if you guys notice this pattern, what's happening is every time our length goes up by 1, our widths are going down by 1. So I'm going to continue that pattern all the way down this and then do all the calculations at the end. So we have 4s, 5s, 6, 7, 8, and 9. And if you notice, that gives us 4, 6, 5, 4, 3, 2, and we're not going to go lower than 1. Okay? Now, if I quickly look over all of these, they're all going to add up to 20. 4 and 4 is 8, 6 and 6 is 12, 8 and 12 is 20. If you guys want, you can go through them all checking that the perimeters are right. But what's most important is that we solve all of the areas. 3 times 2 is 21. 3 times 7 is 21. 4 times 6, 24. 5 times 5, 25. 6 times 4, 24. 3 times 7 is 21. 8 times 2 is 16. And 9 times 1 is 9. So, if you guys notice, what's happened on this chart is we've slowly built up. We've peaked at the number 25. That was our largest area. And then from there, our max area started to drop again. And the reason for this is because our shapes repeated each other. So, if you guys notice, some of our examples were 2 meters by 8 meters. Then we went 4 by 6, 5 by 5. When I went down to 4 by 6 again, I'm using the exact same shape from above. It's just the widths and the lengths have switched with each other. So, by making this chart, I was able to figure out that the 4-sided shape that maximized area best was the square. And what you're going to discover is this is always the case. When we're making 4-sided objects with a limited perimeter, our perimeter was 20, the max area, the shape that will maximize our area, is a square, always. The closer you get to the square, the more area you guys are going to have. So it makes most sense for this farmer to build a pen that is 5 meters long and 5 meters wide. That way his area in the pen is 25 meters squared, using his 20 meters of fencing. Alright, same question. This farmer then decides, you know what, I have a barn, so why don't I use the barn as part of my fencing for this pen that I'm going to make for my sheep. So again, the farmer still has 20 meters to work with, but he's decided this time that he's going to use, and that's supposed to be a barn at the top there, he's usually to use the barn as part of the fencing, and he's going to create some 4-sided shape off the side of the barn. So in other words, he needs to use the perimeter for 2 widths and 1 length. This is already there. This part is already there. It's the barn. The sheep clearly can't go through the barn. So he's going to use that so that he can create a larger pen. So again, our perimeter is 20 meters. But this time we have to find a shape that's going to maximize area when we only need to use 3 sides of the 4-sided shape. So again, I'm going to make a chart. So, before what we did is we were finding it in our head. I'm going to show you a formula for this specific shape. Again, remember, we are creating a 4-sided shape, some kind of quadrilateral, but one of the walls we don't need to use for. So we only need to use for 3 sides of the 4-sided shape. So our perimeter will be the 1 length plus our 2 widths. And what we're going to do is by trial and error, we're going to input numbers in for the widths and solve for the lengths. So, if my widths are both 1 meter long, I'm going to plug 1 in for the W. And we know that our perimeter is maxed out at 20. We don't have any more fencing, there's not much else we can do. 20 is equal to L plus 2 times 1. We're trying to solve for L. 20 equals L plus 2. When I bring the 2 to the other side, I get 18, or 20 minus 2. I'll write that in, sorry. So our length will be 18 in this instance. Okay? I want you guys to continue following that chart for the next little. Okay, let's continue this pattern. Now if the widths are both 2, we're going to plug it into our formula again. P is equal to L plus 2W. This time our widths are 2. And our perimeter again is 20 because that's the max. So we have L plus 2 by 2. 20, L plus 4. We bring 4 to the other side, becomes 20 minus 4. Our L is now 16. So, I want you guys to recognize the pattern that's happening. As our widths go down by 1, up by 1, our lengths go down by 2. So if I keep that pattern, 3 and 3, what will my next length be? 14, good. 4 and 4, 12. 5 and 5, 6 and 6, 7, 7, 7, 8 and 8 will be 4, 9 and 9 is 2, and 10 is 1. So, we can't have a side that's 0 length. Otherwise, we don't have a shape anymore. So we've put down all of our widths and lengths, and we know they're going to add up our perimeter to 20. What I now need to do to find area once again is I need to multiply a width and a length. So 1 times 18 gives me an area of 18, and it's all meters squared. 2 by 16 is 32. 3 by 14 gives me 42. Yep. 12 by 4 gives me 48. 10 by 5 gives me 50. 6 by 8 is going to give me 48. 7 by 6 will give me 42. 8 by 4 will give me, oh, that's 32. Yeah, 32. 9 by 2 is 18. 10 by 1 is 10. Okay, so again, if we look through our maximizing of area, 50 meters squared is what worked best. And when it was 50 meters squared, what happened was our widths were both 5 and our length was 10. So anytime we need to maximize area with our perimeter only creating 3 sides of the shape, we need a length that is twice as long as the width. So if you notice, our width was 5 and our length was 10. To maximize this area, we'll always need our widths to be twice as long as the length. Sorry, I said that backwards. Our widths will be half the size, or our lengths will be twice the size of our widths. Okay? So in other words, the length is equal to 2 widths. Keep writing it backwards. There we go. Length is equal to 2 widths. That's our formula. Okay? Yeah, whenever we have a 3-sided shape, we're trying to create 3 sides of our 4-sided shape to maximize area. So when the farmer did this, his area doubled. He was able to go from 25 meters squared if he created all 4 sides with his perimeter to 50 meters if he decided to make it off the side of the barn. A much larger area. Homework. Yesterday's homework 1 to 7, 12, 14. Today's 8, 11, 13, 18 on the same page, 94.